Have you ever used a mortar and pestle, to grind up some spices in the kitchen? Okay, now I want you to imagine that, but on a massive industrial scale. Picture this, a giant heavy wheel just rolling around and around in a stone trough, absolutely pulverizing anything that gets in its way. Well, that's pretty much what an end runner mill is. It's a machine that takes that ancient, simple idea and combines it with pure brute force. So let's dive in and break down how this incredibly powerful piece of equipment actually gets the job done.
All right, here's what we've got on tap. First, we're going to dig into the core principle that gives this mill all its muscle. Then, we'll take a look at its surprisingly simple anatomy before watching the whole process in action. From there, we'll check out where you'd actually find one of these things in the real world, and we'll wrap it all up with a final verdict on what makes it such a specialist in its field. So, what's the secret sauce here? What makes it so powerful? It's not some complicated computer or a super high-speed motor. Nope. It all comes down to two really basic physical actions that work together in, well, a kind of perfect destructive harmony.
First up, you've got compression. This is the most obvious force at play. It's just the sheer weight of that massive wheel, which is often made of solid granite, pressing down. It squishes the material against the hard circular base or bed. It's pure, simple, top-down, crushing power.
But that's only part of the story. The second force is something called attrition. See, as the wheel is rolling, it's not just pressing straight down. It's also scraping and rubbing the material against the bed. This creates a shearing action, which grinds those already crushed little pieces into an even finer powder.
Okay, so let's break that down. Think of it like this. Compression is that vertical, downward force that uses weight to break the material apart. Attrition is the horizontal, sideways force that uses friction to grind it down. It's this 1-2 punch that makes the mill so ridiculously effective. The initial crush from compression creates all these smaller pieces with a ton of new surface area, which then lets the shearing force of attrition do its job way more efficiently.
So we know the physics behind it, but how is a machine that generates these forces actually put together? The real beauty of the end runner mill is just how simple it is. Let's take a look at the few key pieces that come together to create all that crushing power.
There are really only a handful of key parts here. You've got the bed, which is that heavy circular base. Then, of course, the star of the show, the heavy wheel that does all the crushing and grinding. A shaft connects that wheel to a motor to make it turn, and a lot of them have a scraper. It's just a simple blade that continuously pushes material back into the wheel's path, making sure nothing gets away without being ground up.
All right, so we've seen the parts and we get the principles. Now let's put it all together and actually walk through what a typical grinding cycle looks like.
So picture this. First, you load the raw material, let's say it's some really tough herbal roots, onto the bed. Then the wheel starts its slow but super powerful rotation. As it moves, it's applying both that compression and attrition, just breaking and grinding those roots. Meanwhile, the scraper is doing its thing, pushing everything back under the wheel over and over. This just keeps going until you get the exact fineness you want. Finally, the finished powder is collected. Simple and so effective.
It's a powerful tool, for sure. No doubt about it. But what's it actually for? I mean, where does this kind of old-school technology really fit into our modern world?
You'd actually be surprised. The end runner mill is a total specialist. It's found its perfect niche in industries that need its very specific, very powerful grinding abilities.
This is where its brute strength really pays off. I mean, think about trying to get the active ingredients out of really hard materials, like certain herbal roots or tree barks. This is the perfect tool for that job. In the pharmaceutical world, that same power is used to prepare really thick ointments and pastes. It's also a key tool in traditional Ayurvedic medicine, and one reason for that is because its slow, powerful grinding doesn't create the intense heat you get from modern high-speed mills, which could damage delicate compounds in the herbs. And believe it or not, it can even mix solids with liquids, which makes it surprisingly versatile.
Okay, so with all that in mind, what's our final takeaway here? Is the end runner mill a go-to piece of equipment, or is it basically a relic of the past? Let's weigh the pros and cons.
So the trade-offs are pretty clear. On the plus side, it's super simple to build and run. It can handle both wet and dry grinding, which is great, and it absolutely excels at crushing really tough materials. But on the downside, it is not very efficient for huge, large-scale production runs. It's also pretty labor-intensive, and all that friction generates a good bit of heat, making it a bad choice for delicate, heat-sensitive ingredients.
So when you get right down to it, the end runner mill isn't trying to compete with those high-speed mass production grinders. It's not supposed to. It's a specialist. It's designed for those specific,
tough, small batch jobs where its powerful, dual-action grinding is exactly what you need.
And that kind of leaves us with a final thought, doesn't it? In our world of ever-increasing complexity, what other elegantly simple technologies from our past are still playing a totally indispensable role today? It's a fascinating question, and it really makes you think about the enduring power of a great, simple design.